Welcome to lessons 4.7, adding and subtracting algebraic fractions. So let's first hear the drums. Cool, drum pad. Okay, not really related to what we're doing, except for the anticipation of the answer. I know you can't wait to see what 5/6 plus 8/9 is. Okay, so we need to start with something we remember so that we can add and subtract regular fractions so that we know how to add and subtract algebraic fractions. So the first step says find a common denominator. This is also called finding the LCM of all the denominators presented in the problem. So if I have 5/6 plus 8/9, I want to figure out what is the LCM of 6 and 9. Now, if you don't know how to do that mentally, or if you can't just figure it out by looking at it, then you need to go to the steps that you learned in the previous lesson, which is prime factorize them both and find their LCM. But I think you might be able to think this one through. 6 and 9 both go into 54, but don't they also go into 18? Wouldn't that be their least common multiple? So let's rewrite the fractions with a denominator of 18. So in order to get 18 for my first fraction, I have to multiply 6 by 3, which means I also have to multiply 5 times 3. So I get 15 over 18. If I multiply 9 times 2, I get 18. If I multiply 8 times 2, I get 16. Okay, so now I've done number 1 and number 2. Number 3 says add the numerators, keep the same denominators. So that should be singular, not denominators. It should just be denominator. But basically, I want to keep 18 as my denominator, and I want to add 15 plus 16, which gives me 31. Okay, am I done? No, I need to reduce, which is step 4. I've done step 3, now I want to reduce. Well, 31 and 18 actually is already reduced, but I should write it as a mixed number. That would be better form. So the answer here is actually 1 and 13/18. Final answer. Okay? So that should be review from last year. Now let's move on so that we can see, all right, well, what is it going to look like now? A drum set. Let's hear the drum set first because that's always so exciting. Okay, I kind of like the other one better, actually. You'll have to tell me what you think. So here we go. We've got x's in this problem. So this makes it an algebraic sum. So we want to find a common denominator. I'm still looking at two numbers, 5 and 4, in the denominator. So I want to figure out, okay, what if 5 and 4 both go into? 20 would be their least common multiple. So I'm going to check that one. And I'm going to rename the fractions with the new denominators, remembering to multiply the top and the bottom by the same factor. So my new fraction is going to have a denominator of 20. This one I multiply the bottom by 4 and the top by 4. 3x times 4, or 4 times 3x. Remember that in between 3 and x is just multiplication. So it's basically 4 times 3 times x. So it's 12x. Up here I'm going to multiply by 5 and by 5. I get my numerator is 5x. So now I have 12x over 20 plus 5x over 20. And I'm on to number 3. Number 3 says add the numerators and keep the same denominator. So I keep the same denominator of 20 and I add the numerators. Can you add 12x plus 5x? Yes, you can. 12x and 5x are like terms. They both have an x in them. So 12x plus 5x is 17x. Sometimes you can't add them, and so you would just write the sum. If it was 12x and 5, you would just write 12x plus 5 over 20. Okay, so we did this. Now we have to look for reducing. Well, I can't get rid of the x. It has nothing to reduce with. And 17 over 20, neither one of 17 and 20 do not share a common factor except for 1. So my final answer is 17x over 20. Okay, hopefully that didn't feel too hard. Now we're going to get into one that's just a little bit harder. But first, the music. Oh, isn't that lovely? Okay, so now we're going to go to 7 over 4x plus 5 over 3x. I want to think about what 4x and 3x have as an LCM. And I'm not really sure. So if you were to think about the prime factorized form of this, let's do it over here. 4x would be 2 squared times x. 3 is already prime, so it would just be 3x. So basically, I want to figure out what's the LCM of those. Well, they don't have anything in common, so I'd have to do 2 squared times 3, except they do have an x in common. Excuse me, I should have said that. They have a factor of x in common. So I can write x in the LCM. I don't need x squared, but I do need 1x. So if I multiply this all the way out, I'll get 12x as my LCM. Well, look at the 4x and the 3x and say to yourself, could I have done that without the prime factorization? Because if you can, you should. 4 and 3, you know 12 is going to be the LCM, and it has to have an x in it because they both have to go into it. So 12x is going to be my denominator. Now, what do I multiply 4 by to get 12x? Well, I just need to multiply it by 3. So that means I just need to multiply my numerator by 3. So I get 21 over 12x. On the other fraction, I'm going to multiply by 4 to get 12x. I'm going to multiply my numerator by 4, and I get 20. So now I've got 21 over 12x plus 20 over 12x. Let's remember what the directions said. On the last page, it said to keep the denominator the same and add the numerator. Well, can I add 21 and 20? I sure can. So I have 41 over 12x. Now you say to yourself, can I reduce this? And you can reduce this. You can make it into a mixed number. But I'm going to say when you have variables in it, you should just reduce a common factor and leave it improper if it's that. So I'm going to say this is my final answer. Okay, good luck. I think you'll see some of these problems within the homework assignment, and hopefully this will help you to be successful with those. Good luck.